In hydrology, discharge is the volume rate of water flow, including any suspended solids, dissolved chemicals, or biologic material, which is transported through a given cross-sectional area. Synonyms vary by discipline. For example, a fluvial hydrologist studying natural river systems may define discharge as streamflow, whereas an engineer operating a reservoir system might define discharge as outflow, which is contrasted with inflow. Catchment discharge. The catchment of a river above a certain location is determined by the surface area of all land which drains toward the river from above that point. The river's discharge at that location depends on the rainfall on the catchment drainage area and the inflow or outflow of groundwater to or from the area. Stream modifications such as dams and irrigation diversions, as well as evaporation and evapotranspiration from the area's land and plant surfaces. In storm hydrology, an important consideration is the stream's discharge hydrograph, a record of how the discharge varies over time after a precipitation event. The stream rises to a peak flow after each precipitation event, then falls in a slow recession. Because the peak flow also corresponds to the maximum water level reached during the event, it is of interest in flood studies. Analysis of the relationship between precipitation intensity and duration and the response of the stream discharge are aided by the concept of the unit hydrograph, which represents the response of stream discharge over time to the application of a hypothetical unit amount and duration of rainfall. The amount of precipitation correlates to the volume of water that subsequently flows out of the river. Using the unit hydrograph method, actual historical rainfalls can be modeled mathematically to confirm characteristics of historical floods, and hypothetical design storms can be created for comparison to observed stream responses. The relationship between the discharge in the stream at a given cross-section and the level of the stream is described by a rating curve. Average velocities and the cross-sectional area of the stream are measured for a given stream level. The velocity and the area give the discharge for that level. After measurements are made for several different levels, a rating table, a rating curve may be developed. Once rated, the discharge in the stream may be determined by measuring the level and determining the corresponding discharge from the rating curve. If a continuous level recording device is located at a rated cross-section, the stream's discharge may be continuously determined. Larger flows can transport more sediment and larger particles downstream than smaller flows due to the greater force. Larger flows can also erode stream banks and damage public infrastructure.